Hello everybody and welcome to another math video. Today I will be showing you guys how to take the derivatives of some functions here using all of the rules that we know, and these are sort of exponential and logarithmic functions as well as a trig one there at the end. So starting off with the first one, taking the derivative, oh my gosh, there's a fly here. Taking the derivative of the first one, excuse me, okay, our y prime. So this is my outside function here, and there's 5, right, to some exponent, and that exponent is going to be my sort of my inside function, okay? Because I'm saying that because we have to use the chain rule here as well, okay? So what it's going to look like is it's going to be 5 x to the third exponent, and remember, when you're taking the derivative of something with a base that's not e, right, you have to write that down, because normally even if we take the exponent with a base e, you're multiplying it by ln e, but nobody ever writes it down because ln of e is just equal to 1. But this time it's not e, so we do have to write it down. So it's the natural log of 5, and we have to multiply that by the derivative of our inside function, which is x cubed, and that's just going to be 3x squared. Okay? That is the derivative there. Okay? This one here. Moving on. Here we have, this is going to be the product rule. Okay? We have two functions here. We have e to the 5x, and we have log base 3 of 7x to the exponent of 4, okay? Just really quickly, we need to do some side work for this, because this, not pretty, okay? We want to change that. What I'm going to do is I'm going to bring this thing out to here, and I'm going to change it out here. So we have log base 3 of 7x to the power of 4, okay? Well, what I want to do is, I don't want log base 3. I want the natural logarithm. So to change that, I'm going to go natural log of 7x to the power of 4 all over the natural log of 3. Okay? This is just your classic change of base formula. So now this is what we're taking the derivative of. Okay? So really, to take the derivative of this thing, I'm going to bring my 1 over natural log of 3 over to the front, and I'm only going to take the derivative of this part, because 1 over natural log of 3, that's just a constant, so that's going to come down with me. I want to take that part and move it to the outside, and I only want to take the derivative of this part inside, which is the natural log of my 7x to the 4. Okay? That's what I want to take the derivative of, okay? Now, how do we do that? This right here, we have the natural log of the product of two things. It's the natural log of 7 multiplied by the natural log of x to the power of 4. So I can split that up using our rules of logarithms, right? So I'm just going to take the derivative of this, and then I'm going to return to this part here, okay? I can rewrite this part like this. Natural log of 7 plus the natural log of x to the power of 4. Now I can use my handy rule that whenever we take the log of something, I can move that exponent and bring it down, right? But remember, I'm still taking the derivative of this whole thing, but I'm just going to rewrite it here. I have natural log of 7, and then I have plus 4 natural log of x, right? Now, taking the derivative of this, well, the derivative of this isn't really that bad, because this is just a constant, so the derivative of that is just 0, and the derivative of this is, my constant out front is 4, the derivative of natural log of x is just 1 over x, so it's just going to be 4x. Okay? So, returning back up here, this is my constant, right? It stays out front, and then the inside, the derivative that I just came up with here, or that I just did right here, is just going to be 4 over x, right? So the derivative of that is just going to be 4 over x natural log of 3, just like that, okay? This is what we're going to use for the derivative of this part here, because we have to do product rule here, remember? So what we have here, to do the product rule, I'm going to take the derivative of the first part, which is just going to be e to the 5x, multiplied by 5, the derivative of the top, right? Oh boy. Okay, just like that, leaving this part alone. So I have log base 3 of 7x to the 4. Plus, I'm going to write that part down here. I'm going to leave the first part alone, e to the 5x. And I multiply by the derivative of this whole part, which we figured out down here was this. 4 over x natural log 3, right? And this is multiplication here. Just like that, okay? Now, moving on to this part. This one is super, super fun because it is a chain rule inside of a chain rule inside of a chain rule. It's like Inception over here. Let's try and figure it out. So, y prime, right? The derivative of my outside portion, okay? So I have my outside, the 5 just comes along for the ride, okay? So I don't care about the 5, I'm just gonna write it down at the front, and I'm gonna leave it like that, okay? This is my outside portion. Then I have an inside portion, which is my sine of 10x. Then I have another inside portion, which is my 10x. So, 5 multiplied by the derivative of this part, oh, that's going to be negative sine, right? So I'm going to put a negative 5 here at the front. That cos is going to switch to a sine. My inside is going to remain the same, right? So I have to just copy it down. 10x, right? Now I have to multiply it. I did this part outside. Now I got to do the next part, which is my sine of 10x. Well, the derivative of sine of 10x is just going to be cos of 10x, okay? So here you're going to have multiplied by cos of 10x. Now, my other function, the inside of this function, is 10x, the derivative of which is just 10, okay? So I have another 10 at the end there. And if you want, you can just rewrite it as negative 50 sine of 10x, and then here you just have cos of 10x on the end there. Yeah, pretty funny, that one. Multiple chain rules, super fun. Well, there you have it. Hope you enjoyed it, and have a good one.